And this differential equation is dy over dx equals e to power 2x. Mohammed, now we check now yourself and try to solve independently this equation. And you can use your notes from the previous class. These problems are similar to what we did. Did you solve, Luca?
Yes.
Oh, okay, very good. Sandro?
Yes.
Very good. Mohammed?
Yes, kind of.
Oh, hi, Emmanuel. Emmanuel, now we are solving this differential equation and you should check yourself. Try to solve independently.
Yeah, I was in the toilet.
Okay. And what is your answer, Luca? Can you tell me your answer?
Y equals e to power 2x plus c.
E to power 2x plus
C.
And Sandro, what is your answer?
I agree with Luca.
Okay. And Mohammed?
Yes, I agree.
Okay. Let's check. And let's check your answer. We have dy equals e to power 2x dx. So this is your answer. And now let's check it. Now I will take integral from the both sides. Dy equals integral e to power 2x dx. Integral from the left side, it's y. But question is, what is integral for e to power 2x dx? I guess you decided that it's e to power 2x. But why? We have no basic integral e to power 2x dx. What we have in the basic integrals, it's e to power x dx. Or we can write down integral e to power t dt. And it's e to power t plus c. But here we have not x, but we have 2x. But what we can instead dx, write down d to x. And I will do it now. Integral e to x d to x. Now let's check. Is it correct? And how to check? To check, we should find differential of 2x. We should find differential of 2x. And differential 2x is going to be 2 times dx. Do you agree? Because derivative of 2x, it's 2. And d to x, it's 2 times dx. So, but we need that this expression and this expression must be equal. And that's why we need here coefficient 1 over 2. Now, Now we can write down that y equals 1 over 2 e to power 2x plus c. So your mistake was that you mistakenly wrote down that e to power integral of e to power 2x. It's e to power 2x, but it's not. Okay. Next example, let's give next example. Dy over dx equals e to power 0.1x. It's very similar with previous problem.
I solved it.
Okay, what is your answer, Sandro?
My answer is y equals 10 times e to power 0.1x plus c.
Okay. And what is your answer, Sandro?
That's my answer.
Oh, okay. Luca?
E to power x. I think that Sandro is correct.
Okay. Mohammed, what do you think?
I agree also.
Okay. Emmanuel?
Yes, yes, Sandra is correct. 10 raised to power e.
Oh, let's welcome Otto. Otto joined.
Hello.
Hi.
Otto, we are solving differential equations. Have you heard? Are you familiar with differential equation?
Yeah, of course.
Oh, very good. So it contains derivative of function and function as well. And solution of differential equation, it means to find function. Okay. Now let's check this Sandro's solution, this answer. So we can write down dy it equals e to power 0.1x dx. Now we will take integral from the both sides. Dy equals integral e to power 0.1x dx. Y equals, and here we should write down, instead dx, we should write down d 0.1x. But to keep equality, we need here, I agree absolutely, we need here coefficient 10. So finally we have y equals 10 times e to power 0.1x plus c. Okay, very good, Sandro. Okay, next example. In this next example, now we need to find one particular solution. And let's this example. Dy over dx equals square root x. And here, given extra condition that y of 0 it equals 0. Please start solution. So y equals. Now, what we need now? We need to find integral of square root of x. And to find this integral, any idea how to find this integral?
Yes.
Yes.
How, Sandro?
This is y equals x to power 1 over 2.
Okay, it's very good idea. So square root, I can write down as x to power 1 over 2 dx.
Yes.
And now, by formula of integration of power function, we can write down x to power 1 over 2 plus 1,
Yes.
and in the denominator 1 over 2 plus 1, and plus 3. It's going to be 1 over 2 plus 1. It's 3
One.
over 2, 3 over 2. And I can write down here 2 over 3 x to power 3 over 2 plus c.
Yes.
Okay, if you agree, I will write down it in the solution. 2 over 3 x to power 3 over 2 plus c. Okay, now they are given conditions that y of 0 it equals 0. So this 0 I have to plug instead y, and this 0 I have to plug
X.
instead x. And so we will have 0 equals 0 plus c, and c equals 0. And now our final solution, y equals 2 over 3 x to power 3 over 2. Okay. Any questions about this problem?
No. No, sir.
Okay, very good. Next example. Next example is dy over dx equals e to power x minus 3, and also given y of 3 equals 5. So first of all, we need to find general solution for this differential equation. Do it yourself, please. And if needed, I will help you. Otto, do you have any questions?
Right now, no.
And are you solving now it?
Yeah.
Oh, okay. Do you have a camera on your laptop?
Yes, I have.
Oh, can you turn it on?
Yeah, just a minute.
Oh, very good, very good. Good to see you. Sandro, did you solve?
Yes.
Really? Did you find the general answer or particular function?
General answer.
Okay. And let's write down your answer, and then I will check it. Y equals
e to power x minus 3 plus 4.
plus 4.
Yes.
Okay, let's check. So this is not general function, but it's particular function.
Ah.
General
Okay.
function when it's when they involve C.
Okay.
When we find C, it means we have one particular function. Okay, let's solve and we will check Sandro's solution. Okay, so we have dy
Mr. Soto.
equals e to power x minus 3 dx. Now we will take integral from both sides. Integral dy equals integral e to power x minus 3 dx. Here we have y, integral dy, it's y. As for second integral, we have to write down here dx minus 3. Do you agree, Otto?
Yeah.
So here we have x minus 3. And I will write down here dx minus 3. And if needed, we can check it. And how can we check it? dx minus 3, it's derivative of x minus 3 times dx. But derivative of x minus 3 is just 1. So dx minus 3 and dx, they are just equal. Okay, let's now continue. From here, y equals e to power x minus 3 plus c. Now we need to use given condition to find particular function. Otto, got it what I mean particular function? In this function,
Yeah.
there are infinite number of functions because c is constant, c is real number, they are infinite real numbers, so here we have infinite functions. But among these functions, we need to write down one particular function which satisfies condition. And what this condition, y3 equals 5. So this condition, y3 equals 5. And what it means? It means y I will replace by 5 and x I will replace by 3. So we have 5 equals e to power 3 minus 3 plus c. Muhammad, and what is e to power 3 minus 3?
What?
E to power 3 minus 3. What is 3 minus 3? It's 0. And what is e in the power 0?
Is 0.
1.
No, Emmanuel. It's 1. It's 1. Any number. Any number. In the
Raised to power 0 is 0. That's what it told us.
It's 1.
Zero.
It's 1.
Zero.
1. 1. Any number in the power 0. It's 1. Any number. Look, any number. Let's denote it by a. In the power 0. It's 1. Any number. Any number, it means, for example, 7 in the power 0. It's 1.
Okay.
1 million in the power 0. It's 1.
0 power 0.
Oh, 0 power 0, it's a complicated question, and let's talk it later. But now, so 5, it equals e to power 3 minus 3. And so we have here c equals 5 minus 1, and 5 minus 1 is 0. So what is our final answer? Sandro's answer. It looks absolutely right. E to power x minus 3 plus 4.
Sandro is small Wanka.
Okay, now let's do our problems more complicated. And let's now dy over dx equals 2 times y. This equation is different. It's different from the previous problems because in the right side, we have function. We have unknown function. In the previous exams, in the right side, we had only variable x, not function. But now we will try to solve this differential equation, and we can write down in the same way, dy equals 2y dx. But now it's not good idea now to take integrals from the both sides, because in the right side I have dx, different variable, and there I have y. But what is good idea? Good idea is to divide both sides by y, and in the left side I will have only function y, and differential of this function. I mean, I will divide by y both sides, and we have dy over y, it equals 2 times dx. Any questions so far?
No.
Okay, very good.
Nope.
Now let's take integrals from the both sides. And we have integral dy over y equals integral 2 dx. But 2 is constant, I can move out across integral sign. And I can write down 2 dx. Okay. Now, what is integral of dy over y? It's basic integral.
ln.
Absolutely. It's ln absolute value of y. It equals
2x.
absolutely.
Ln y or ln y plus c?
Y plus c. Do you mean ln y and then plus c? I will write down c here. Look up.
Yes.
I will write down c here.
2x plus. Okay.
Yes. One constant is enough. I can write down also from the left side. Also, I can write down here 5 times c, 100 times c, but it does not matter. What does matter? We need constant. Okay. Now let's recall property of logarithm. And property of logarithm, I mean, when we have logarithm with base a, b equals c. It's b equals e to power c. Or e to power c, it's b. In the same way, I can write down here y equals e to power 2x plus c. So from here, look, I can erase it, this formula, and from here, y equals e. And what is this e? This e is base of ln, e to power 2x plus c. Is it clear?
Yes.
No questions?
No, I don't have.
I have one question. Do we need here to write down absolute value of y? Here we have absolute value of y. It's obvious. But I did not write here absolute value of y. Do we need it?
No, it's not necessary.
Why?
No.
Why?
Because we have constant and it may also be negative.
What we have, Sandro?
Constant plus c.
Yes, we have constant plus c, but how this constant affects sign of y? In the right side, here we have exponential function, e to power 2x plus c. And it's always positive, this function. It's always positive. E to power, e, it's positive. It's real number, it's positive. And positive number in the power of any number, it's always positive. And that's why we don't need absolute value. Okay, now I will represent it in different view. And if you agree, I will instead C, I will write down C sub 1. And why I need, I will show now. I can write y equals e to power c1 times e to power 2x. I used very well-known formula. Luca, I used very well-known formula.
Yes.
A to power n plus m,
Uh,
it's e to power n times e to power m.
I know it, but maybe my connection is bad, wrong.
Oh.
Uh,
Now, what can you
Oh,
say?
Hearing.
the
What,
connection is bad, but I checked my connection and it's 5 stars. ამ ჩემი მეც მიჭედავს და ჩემთან კარგად იჭერს და რა
oh,
დაჭერა, არ ვიცი, რაღაც პრობლემა აქვს.
ჩემთან
you can't hear me now?
right now yes, but sometimes my voice is too
Okay.
But it's okay with me.
Tell me when you can't hear, and I will repeat.
yeah.
Okay.
Okay.
So, and when we will finish our lecture, let's then check speed of our internet connection. Okay, I will check and you check and okay.
check
And we will find fault.
the problems.
We will find fault of our disruption. Okay, so here we have e to power c1. And what can we say about e to power c1? I think it's constant. What do you think? It's constant because e, it's constant number. C sub 1, it's constant number. So it's constant. That's why I can denote it by C, e to power C1. Let's denote it by C. And finally, I have y equals C times e to power 2x.
I have a question.
Okay.
Can e to power c be 0?
Sandro, say again.
E to power c, can it be 0?
Newer, Sandro, newer. It cannot be 0. It's power function. E, it's a real number. And it's exponential function. And I will remind you graph of exponential function. Look. It cannot be 0. It's always positive. It's always positive. to be more clear, instead you can imagine, for example, 2. 2 in the power x. Can it be 0?
No.
It's always positive. The same with number e. It's always positive. So this is our final answer. This is our solution. Now look carefully and tell me if you have any questions about it.
For me, everything was clear.
So the middle is times, right? E raised to power C1 times E. Yes?
E to power C1, I denoted, Emmanuel, I denoted it by C. I can denote it by C because C is just constant
Number.
and e to power C1, it's also constant because E is constant and power also is constant.
Okay.
Okay, now next example. Next example, dy over dx dy over dx equals 0.5 y, and they are given condition y of 0 is 100. Okay, check yourself and try to solve. Luca, did you start? So we have dy I can write down dy over y equals 0.5
dx.
dx. Do you agree?
Yes.
In previous example, it was first example, and I did step by step, very short steps. And now I can write instantly from this expression, I can write dy over y equals 0.5 dx. Let's continue. Integral dy y equals 0.5 integral dx ln y equals 0.5 x plus c1 y equals e in the power 0.5 x plus c1, y equals e to power c1 multiply e to power 0.5x y equals c times e to power 0.5x. Look very critically. If something is unclear or you disagree, you are free to express your opinion.
E raised to power C1, they are constant number, right?
Absolutely, Emmanuel, you are absolutely right. And that's why I replaced it by C.
Yeah, I understand.
Because idea of C is constant number. Okay, now let's take into account our condition. And what is our condition? Y sub 0
Equals 100.
100.
equals 100. Okay, so what it means? It means x, I have to substitute by 0, and y, I will substitute by 100.
Yeah.
So 100 equals c times e 0.5 times 0. And what is it? E to power 0. It's 1.
1. Yeah.
It's 1. It means c equals 100.
100. Yeah.
And now I can write down particular function. This particular function is going to be y equals 100 times e to power 0.5x. Any questions?
No, sir.